would like to talk about some properties of functions today, especially what we would call even and odd functions. All right, well, let's review what we remember about a function and what the definition of a function is. And our definition of a function is that for every input, there is only one output. Now this is a more simplified definition of a function. So the idea is, and you might have seen a more fancy definition state that for every element of the domain, which is our input, there is one and only one element of the range, which is our output. Okay, so that just means that in a function, you can think of it as a machine, is that every time I put something into it, I can only get one thing out of it. Okay, well, there are certain machines, per se, that are what we call even. And an even one is going to look like where f of negative x is equal to f of x. Now you're probably thinking, well, that doesn't make a lick of sense. And basically what it is saying is that if I were to plug in 3 into this function or machine, like I like to think about it, but if I plug in a 3, I would get out the exact same thing as if I were to plug in a negative 3. So, and they still would only go to one thing. So whether it's 3 or negative 3, it still only goes to one output, hence a function. But the thing is that if I plug in a 3 or I plug in a negative 3, it goes to the exact same thing. And that makes it even. Or, like we like to visually see it, it is symmetric about y-axis. Okay, so that's the idea of even. Well, what about these odd? These odd functions, the odd functions, are stating that negative f of x is equal to f of negative x. All right, well, again, this looks confusing, but the idea is, and let's take my f of x again. If I had this f of, let's say 3. So x is 3. So if I had this f of 3 and I get out a 5, well, what this odd function means that is if I plugged in f of negative 3, I would end up with a negative 5. So the idea is if I negate the x, like if I negated that 3 and got a negative 3, well, when I plug in a negative 3, I end up getting a negative 5 out of it. And we see another symmetry, and this is symmetric about origin. Okay, so let's look at some visual examples. Taking a look at this one, I hope you can see that here is our y-axis, here's our x-axis, and I hope we see this symmetry. If I were to take this and fold it over, I would see that it would match up perfectly. This is an even function. And let's see how it actually applies to the formula I was just stating about that f of negative x equaling f of x. So let's get some arbitrary values out here. So let's say I had let's say this is a 5. And if I had a 5 and I go up here, and we're just doing an approximation. So let's say I plug in a 5 and I get out a 10. Okay, so f of 5 is going to produce a 10. Well, let's say I did f of negative 5. So let's come on over here, and if I plugged in f of negative 5, I see that I also get out a 10. And that shows me, and I wanted you to see how that even function, how this messiness, how it makes sense. So if I put in an f of 5, I got out a 10. But if I negated that and put in f of negative 5, I also got out a 10. And that is my even function. And see the symmetry there around the y-axis. Okay, well, let's look at the odd function. In the odd function here, let's recall, I said negative f of x is equal to f of negative x. All right, well, let's get some different points. Let's just hypothetically think. Let's say we had a 2, okay? Well, let's say that f of 2, it produces let's say a 4. All right, again, I'm just coming up with some values so you can understand how this is going to work. The idea is if I took an f of negative 2, so let's go over here and let's do negative 2, what I got out, this point right here, would be a negative 4. So you see how it satisfies this particular condition. So if I know that f of 2 is 4, well, if I did f of negative 2, I would get out a negative 4. All right, well, the most common one that we can see in this particular function, and again, notice this symmetry. This is a symmetry about the origin. So if I had this right here, and if I were to flip and flip, it would line up perfectly right here. So if I were to flip it over the y and then flip it over the x, here I would land. Another way to look at it is if I flipped it over the x and then flipped it over the y, I would land right there. That's our symmetry about the origin. One of the most common odd functions is our cubic function. So let's add a different, let's say this is a g of x is equal to x cubed. Let's see how this matches with what I had stated before. All right, let me change some colors for some clarity here. So what is g? Let's see, what is g of 4? All right, well, g of 4 is going to be 4 cubed. And 4 cubed I know to be 4 times 4 times 4, which is going to be 4 times 4. That's 16 times 4, which is going to give me a 64. That's going to be way up here. All right, well, let's g of negative 4. Well, g of negative 4 is going to be negative 4 cubed. And that's our negative 4 times negative 4 times negative 4, which is going to end up giving me a negative 64. So you see how that satisfies this particular condition. When I plugged in a 4, I got a 64. Well, if I negate that and plug in a negative 4, I get the opposite of this, which is now our negative 64. Okay, so that is some properties of functions specifying on our even and odd functions.